Alright, here we go. Graph the polynomial, number 1. So before we start, I'm going to notice that this is in factored form. So this will tell me the zeros, or the roots, or the x-intercepts. But we also need the first and last term of the standard form in order to get the end behavior and the y-intercept. So I'm going to do the standard form down here, and to get the lead coefficient, we're going to take the lead coefficient or the lead term in each of these linear binomials, and we have a positive out in front, x squared times x cubed times x1 times x squared. So 2 and 3 is 5, 1 is 6, and 2 is 8. So the lead coefficient in the standard form is x to the 8th. So this tells us it's positive, so we know the right end is up. The degree is even, so we know the left hand is the same. To get the last term, we take the last term in each of these linear binomials. So I'm just going to write it out here. 4 squared, 1 cubed, negative 3 to the 1, negative 5 squared. And if you were to multiply that out, you'd get negative 1200. So that's the y-intercept way down low, negative 1200. Okay. Now to get the roots, we set each of these linear binomials to 0 when we solve them. So I don't think we need to write them all out. I think we can just follow the pattern. If it's x plus 4, the root is at negative 4. If the linear binomial is x plus 1, the root is at negative 1, and then x minus 3 would be at positive 3, and x minus 5 would be at positive 5. So now I'm going to start on the right side. We start right hand up, and as we approach the root at 5, the multiplicity is 2, so it's going to touch and bounce. Then the root at 3 has multiplicity 1, so it's going to go straight through. And then the root at negative 1 has a multiplicity of 3, so it's going to do a change in curvature. And then the root at negative 4 has a multiplicity 2, and so it's going to touch and bounce. And so the graph should look something like that. Yeah, mostly we're interested in the end behaviors, the behavior through the x-intercept, and where the y-intercept is. If we wanted to get the relative mins and maxes, we'd have to use our calculator and do it that way. Alright, so given this polynomial, we need to find the zeros and the multiplicities. So the way that we get the zeros, or the roots, or the x-intercepts, is we set each of these linear binomials or linear monomials equal to 0, and we solve them. So this root would be at negative 1, the exponent is 2. This one, x equals 0, and the exponent is 3. See, x minus 3, the root is going to be at positive 3, and the exponent or multiplicity is 1. Okay so far? Alright, write an equation in factored form for the polynomial shown in the graph. Okay, well, I see that well, first of all, the right hand is down, so I know the lead coefficient is going to be negative. And then I see that there are 1, 2, 3 roots, so we are going to have 3 linear binomials. Starting from, no, we'll just start from the left here. It's negative 3, so we would have the opposite sign, positive 3. We're at positive 2, so this would be opposite sign, minus 2. And this is at positive 5, so it would be at negative 5. Now we have to get the multiplicities. At root negative 3, the polynomial goes straight through, so the multiplicity or exponent is 1. At the root positive 2, it's a change in curvature, so the multiplicity or exponent is 3. And at root 5, it touches and bounces, so its multiplicity or exponent 2. Okay? The last question says graph the polynomial. Well, this one's in standard form, so right away we know right hand up, it's even, degree is even, so the left hand is the same, and we know that the y-intercept is at 12. We don't know the x-intercepts though, but we could factor this. X times x is x squared, two numbers that multiply to 12 and add to 7, plus 3 plus 4. To get the roots, we would set these equal to 0 and solve. We'll have one root at negative 3 and one root at negative 4. And so our graph could look something like that. Okay.